You get burned.
Unless she does magnet on like Saturdays.
Oh, bro, you better.
Okay. Wow, you guys are wound up today. It's better than being asleep, I guess.
That means we're ready to do this.
Yeah, half the people kept out tonight.
Well, hopefully everybody, whether
I
they're
don't
in
wanna
it,
do
or
it.
just come and enjoy.
I totally forgot about that.
Oh, I forgot about these people.
Okay, here we go.
I'm not ready, wait.
Settle.
With all those passports. Yeah, and Munchie didn't one of them.
Hey, the people who are absent don't want to hear all of your chatter. We're starting. Right?
Who's
So I'm
absent?
taping, you guys get recorded.
Oh.
Yeah, you're like, oh,
We
didn't
should
think
record
about
the
that.
next class.
Yeah, because half the people, like Kelsey was in the video last year.
Every once in a while. Okay, so we are gonna kind of get more into, the periodic table today. Adam, some of this is gonna be review. Hopefully some of it, you do remember, listening to your conversations about the vocab. Some yes, some no. So the atom is where we have to start, and it is the smallest particle of an element that has to retain the same chemical and physical properties of that element. So if you look over on the wall, that's the periodic table, and you have that white one in your binder now. All of those little squares or tiles represent an element, like carbon or oxygen or nitrogen. Those are, like each little element has the same properties, whether it's an element here, it's an element somewhere else. If it's carbon, it's carbon, right? So it has those same characteristics, and that's what this is trying to say. It has to have certain properties that make it carbon or that make it oxygen, right? And so like in the Bill Nye, it said that if you take atoms and combine them with other atoms, you end up forming molecules. If it's just like taking the letters of the alphabet, instead of having 26 letters that you form like millions of different words with, you take these 94 naturally found elements, combine them, and you make all the different chemical compounds that make up everything in our world. Right? So it's just taking something small and combining it into something larger. Right? So the atom has two measurable properties, and these are the two things we'll focus on. The atom's mass, so called the atomic mass, and its charge. So we have three possibilities, right? Positive, negative, or neutral. So mass and charge. To get a charge, if you remember from last year when you should have learned about different types of potential energy, electrical potential is one of them. And to get an electrical charge, things had to have an unbalanced number of protons and electrons, right? So if you have more protons, it's going to become a positively charged item. If it has more electrons, it's going to become a negatively charged, right? And then those opposite charges attract, like charges repel, right? All of those things that we already learned about last year and you learned about in 5th grade, that still holds true for this year as well. Right? And so the parts of the atom, and this is probably what definitely should be familiar to you, hopefully, that the protons have that positive charge. What charge do the electrons have? Close. Oh, did I go out of order? What is it have neutron next? What charge do the neutrons have? Brady?
Negative. Wait, what?
I got you all confused. What charge for neutrons? Do they have any charge? Seeing some no's, right? What charge? Yeah, neutral. Yeah, so the protons are part of the nucleus, they're positively charged. The neutrons have no charge. Sorry, I did it out of order, I thought electrons were next. Okay. Those are also found in the nucleus. So you can see in this picture, the protons are showing are these little blue circles. The red are the neutrons. That is kind of like the center. That is where you have most of the mass in the entire atom. Bill Nye showed it with like that little weird shaky ball, and then like he ran 500 meters away. to get to our next part, which are the electrons. And those are the negative ones. All right, so this whole thing is the atom. This is the nucleus. Inside the nucleus, you have your protons and neutrons. This is going to be super important because looking at the different elements, it's the number of protons, neutrons that have a huge effect on what element you're dealing with. Okay. The other thing that's super important is how many electrons are in the outer area, and that's going to determine like how that atom actually reacts. Is it happy where it's at? Is it going to want to join with another? Is it really going to want to join up with something else, or is it going to want to stay by itself? So all of these things have a huge impact on how a certain element is going to behave. And so the electrons are the ones that are, of course, outside. So when Bill Nye was doing his dramatic run all the way 500 meters across that big open, kind of like deserty area, right? That's how far away the electrons are from the atom here. Okay, so obviously the nucleus is found in the center of the atom, and it's made of the protons and neutrons. It occupies only a super small percentage of the entire atom. It has most of the mass, but it takes up almost no space. So it's super, super, super dense and really tightly packed. Okay, lots of mass, but taking up little space. Almost all the mass is found there. So when we're talking about the atomic number of an element, the mass in the nucleus is pretty much what accounts for most of that. So one proton or neutron is almost 2,000 times more massive than a single electron. So the electrons have almost no mass. They're very far away from the nucleus. And so those are just some things that kind of help give you a whole picture, I guess, of what's going on in the atom. All right, so the electrons. These are actually found orbiting around outside the nucleus. So again, if you have that visual of Bill Nye running all that 500 meters away, that's where you find the electrons. So there's all this big open empty space between the nucleus in the center and those electrons that are kind of buzzing around the outside of the nucleus. Electrons can be gained or lost. Right? They're on the outside, so they're the ones that are going to have the most interaction with other elements. And so that means, depending on how many electrons they have, sometimes they're going to give electrons, sometimes they're going to take electrons. And that's going to be a huge part of this unit, next unit, even like the third unit. So all of this stuff that we're learning in this unit, the better you learn it now, the easier the next couple of units are going to be for you. It's not going away. So if you have more electrons, let's say you've taken some electrons from another atom. Well, now you have more electrons. That means that atom would be negatively charged. More negatives, give it a negative charge. So kind of common sense there. A lot of what we do this year, I'm going to ask you to be logical about it. Just think it through. Try not to memorize, because let's face it, you start memorizing things and it's like, shoo, next thing you know, it's gone, right? But if you can actually find little ways to remember it, or just think of things like common sense wise, that usually helps. So if you think about it, electrons have a negative charge. If you have more electrons, now something's going to have that negative charge. If they lose electrons, you've gotten rid of some negatives. Well, now you have more positives, so what do you think the charge will be of that atom? Oh, now you can't talk? You get rid of negatives and you have more protons. Protons are positively charged, so what charge are you going to end up with? Positive, okay? And notice, obviously we're using a plus sign for positive and a negative sign for negative. So there's been lots of different models over the years to show how the electrons are arranged. Again, this is the atom. It's so small, we've never seen one firsthand. So everything we know about it, we just have kind of like done indirect little experiments and things. So as that changes over time, we adjust our thinking. But I'll give you a few, show you a few different ways that things have changed over time, our thinking with the atom and the electron. I'm gonna come back, because I videotape your notes, typically I will do all the videos either like at the beginning or at the end of class that go with today's stuff. So I will keep an eye on the time and make sure that I leave us enough time to do those videos at the end today. So the model of the atom has changed like 4 or 5 times. So this is what is not in your notes. I am not going to test you on like the original atom models and things like that, or who was responsible for it. I think it's important for you to know because the atom is so important, because obviously it makes up everything in our entire universe. So I'm going to go through this kind of quickly, but I think it's important for you to see where this information came from. So a little bit of a history lesson mixed in with our science. So these are the people that have been responsible so far to help give us a good understanding. Democritus, John Dalton, J.J. Thomson, Ernest Rutherford, Niels Bohr, and then finally we're at the stage where we call the electron arrangement in an atom the electron cloud model. So it's not given to us by a certain person or scientist, but it's just kind of like putting everything together into what we believe now. And again, that could possibly change. Okay, so around 400 BC, Democritus proposed that atoms make up all objects, okay? He was right on. He was the first person to think this, and he was right. Pretty amazing, being that it was so long ago. He also thought that atoms looked like a solid sphere. He's kind of right with the sphere idea. Where he was wrong is it's not a solid. Okay, and so Bill Nye said this yesterday. The Greek word means uncuttable or indivisible, and the word is atomos. So we changed that to the word atom, but that's where the word atom came from, meaning uncuttable. We couldn't, just like when he was cutting the cheese yesterday, right? He couldn't cut it anymore without changing that property. So when he got down to the final atom, if you could, that's when you'd have to stop. It can't be divided anymore, because if you start breaking it up into the protons, electrons, and neutrons, it's not the same atom anymore. Okay. So he was pretty right on. The only thing, he was just off with it not being a solid. Then we moved to the 1800s, and he proposed something called the atomic theory, where all substances are made of atoms that cannot be created or destroyed. Okay, and then atoms of the same element are exactly alike. He was correct, right? So all oxygens are the same, all nitrogens are the same, and so you can have different versions of those, which we'll call isotopes, but in general, those atoms, if I say, hey, this is a lithium, then it's going to react the same way as other lithium atoms will. Okay? Atoms can combine in whole number ratios to form compounds. And that's true. That's something that we'll get into when we get to our chemical compounds and bonding. And in chemical reactions, atoms are combined, separated, or rearranged. So he was right on about this, okay? He didn't have like specifics, but this was his understanding. And then from there, it led to J.J. Thomson in 1904. He discovered that electrons, kind of like how they behaved, what they were doing, okay? And so he kind of did a bunch of experiments using electricity, and he discovered that there were these negatively charged particles, and that's what we call the electrons. So atoms are neutral, so he decided if you have a negative part and the whole thing is neutral, there has to be something positive to kind of balance that, right? So he said that there has to be something positive, and he called it this like goo or pudding that the electrons are floating in. So they called this plum pudding. Plum pudding is like pudding that has raisins in it. So I guess he's thinking that the electrons are like the negative plums or raisins, and then the rest of the atom is like this goo that is positive. Now, did he really think it's goo? No, but like that's just like the example that he used. So he was wrong about the goo, but he was right that something is positive. Okay. He was also wrong because the electrons aren't scattered around; they're on the outside, and then the positive protons would be clustered in the nucleus in the middle. So we're getting closer to where we are today. All right. So we'll watch these videos. It's going to show how we'll watch how they were able to kind of figure some of this out. It's easier just to watch the videos. So let's stop there. I think that should get us as far as we need